Hi, so the first thing that I need to teach you to be able to catch up with the class today is a new theorem called Pythagoras' theorem, which is really cool. So Pythagoras' theorem works on the basis of a little formula which is a squared plus b squared equals c squared. Now Pythagoras' theorem only works on right angled triangles, but in our examples that we're using for straight line graphs, they're all going to be right angled triangles, so we can use it for all of the examples. So the first thing I need to do is I'm going to create a right angled triangle from this line that I've been given here. Okay, so I'm going to take a different colour pen and I'm going to show you how I'm going to create my right angled triangle, and I'm just going to draw a line, a dotted line down here, and then one across here. And by doing that, hopefully you can see that in there is a right angle, and now I've created a nice right angled triangle. So the next thing you need to know with regards to Pythagoras' theorem is that it is always this length here opposite the right angle that we label as C. So this C in our equation here relates to this C on this length of our right angled triangle. It's always the length opposite the right angle, and it's always the longest length. Okay, and then these ones here, it doesn't matter which way round we label them, so I'm going to label this one A and this one B. And then we can see that from our Pythagoras theorem formula or equation that we've actually got an A, a B and a C, and they're all featuring terms in our equation. So we need to find the length of C because we want to find the length of our line. The first thing we need to do is work out what the length of A is, and we can do this in one of two ways, which I'm going to show you. First the counting way, and then how we can use the coordinates. So if I count the squares from this corner here up until the point on my line, I'm going to count 1, 2, 3, 4. So this length here is 4. And I'm going to count across here from this point here again, 1, 2, 3, 4, 5. So this length here is 5. And now I've got a value for A and a value for B, and I'm going to substitute those into my formula that I've got up here on my right hand side. So now instead of having A squared, I'm going to replace A with 4, so I'm going to have 4 squared. I'm going to add to that B squared, which is 5 squared, and then that is going to give me C squared. 4 squared we know hopefully fairly quickly is 16. 5 squared is 25, and that's then going to give me C squared. Let's move that over. 16 plus 25 is going to give me 41. And that is equal to C squared. Now I don't actually want to find C squared, I need to find C. So the reverse operation of squaring is square rooting, and I know then that I need to do the square root of 41 is going to equal C. So obviously I can't square root that in my head, so I need to get a calculator, which I just did, and then I've put that in my calculator. I'm just going to show you the buttons that you need to press. Hopefully you can see. So that's my square root button there, so I press square root 41 and equals, and that gives me 6.40. So I'm going to round that to 2 decimal places, and it's going to be 6.40. So C, the length of this line here, is 6.40, and let's just call it centimetres. So don't forget your unit of measure. Now let's do another example. So I'll draw a second line. So if I draw a second line here, just label my axes so we can see. And so this point here is going to be x is first, x comes before y, so this is going to be 1, comma, minus 2, and this point here is going to be 5, comma, minus 5. So the second way we can do this is by using the coordinates, we don't have to draw that triangle. I'm just going to put a little loop around this so you can see that this working here relates to the pink lines, like so. And then I'll do a different colour for the next one. So let's use, what have we got? Let's use purple. Okay, so this time we can do the exact same calculation without having to bother about drawing a right angle triangle by just looking at those coordinate values. If I look at my first coordinate pair, my x value on this pair is 1 and on this pair it's 5. If I look at the difference between 1 and 5, the difference between 1 and 5 is 4. I'm just going to write that in shorthand, is 4. What that's saying is that we started off here at 1 and we've gone across 1, 2, 3, 4, which gives us 5. So 4 and 1, if we added those together, would give us that 5 there. And we can just do that by looking at the difference. We don't need to do that little counting exercise. So the difference between 1 and 5 is 4, which means that's the x value. So it's this one here. I'm going to use a dotted line, is 4. And then if we do the exact same with the second pair of coordinates, so the difference between -2 and -5, well, that's 3. So -2, and -5. And that's going to be my y value, which I'm going to put here. And then you can see I've created that triangle anyway just by doing my little sketch. So we're going to have that as 3 there. We can do the exact same method. Oh, sorry, you can't quite see. The exact same method with a squared plus b squared. So if I come over here, the first thing I do is I always write my Pythagoras equation down to show the examiner that I know what I'm talking about. A doesn't matter, remember, whether it's the 3 or the 4. What does matter is that this one here is C, because it's opposite the right angle, it's the longest side. So a squared, well, let's go 3 squared plus 4 squared equals c squared. 3 squared we know quite quickly is 9. 4 squared we know is 16. That still equals c squared. Let's move up a little bit more. And then last but not least, 9 and 16 we know is 25. Hopefully we recognise fairly quickly 25 is a square number, so if we do the square root of 25, that's going to equal c, and hopefully we don't need a calculator. We all know that 5 equals c. So this length here is 5. Boom. And that is Pythagoras' theorem and how to calculate the length of a line using y equals mx plus c. Any questions? I'm available on Monday, Tuesday and at lunchtime, but remember your homework's actually due from Thursday on Tuesdays. Any questions? Just let me know. Thanks then. Bye.